Hi students, this is Ms. Waldorf here. We are going to learn about stem and leaf plots today. Although you guys should have touched on this in 5th grade, we're going to expand upon this a little bit more and learn about it in a 6th grade context where we are going to have to create our own stem and leaf plots. And then we're also going to have to answer various data analysis questions just based on the values we're graphing. So let's get started. So this stem and leaf plot should look slightly familiar to us. This is how they looked last year. Your stem and leaf plots are composed of both stem and leaf portions. Although they're separated on your graph, they do come together to form each data point. So let's learn a little bit more. A stem and leaf plot is a type of graph that shows data within a certain range. So your data is grouped based on the stems. So the stem is 0, 1, 2, 3, and 4. The key tells us how those stems are used, and it's very important to make sure you read your key to figure out what your stem really represents and what each leaf represents. So the stem is the first number, which is typically in the tens place. In this first stem and leaf plot here, each stem is in the tens place. We know this by looking at the key. This 2 represents the part that's with the stem, and this 3 represents the part that's with the leaf. And together they formed 23, which meant the 2 was the value in the tens place, and the 3 was the value in the ones place, forming 23. Now, the leaves are numbers that are normally in the ones place, such as here, and they're listed in ascending order. So the leaves are found on the right side of your stem and leaf plot, and when they're listed in ascending order, that means they're listed from least to greatest. What's really nice about stem and leaf plots is our data is already ordered for us in here. So we have all of our values listed from least to greatest. Now, it's always important to use the plot's key to make sure you're certain that the values you think are in your stem and leaf plot are actually the ones that are in there. We paid special attention to the key when we were kind of walking through this example, and so we know that each stem is the value in the tens place, and each leaf is a value in the ones place. So now we're going to use this plot to figure out what numbers are actually in there. So for our stem and leaf plot, we're going to start with the values at the top, which would be our lowest ones. This stem has a value of 0, and this first leaf has a value of 5. Now this, in actuality, when I press the 2 numbers together, I would get a number that looks like this. But hardly ever when I write the number 5 would I write it as 0, 5. That 0 in the tens place really means nothing. So when I plot this down here, I'm just going to write a plain 5. Now, the next number has a stem of 0 and a leaf of 7. So that number is just going to be plain 7. That number, again, would have looked like 0, 7. This doesn't really make sense, so we're going to ditch the 0 and just write it as a plain 7. Now we're going to start our next row, and this row has a value of 1 for the stems, which means there's a 1 in the tens place. And then my first leaf is a 1, so this one not only has a 1 in the tens place, but also a 1 in the ones place, forming 11. Then this number here, although it looks like a 2, when we account for the stem, it becomes a 12. Then we have another 2, which we know is not just a plain 2. That is a 12 as well as the last one, not a plain 2. This is a 12 because you need to account for not only the stem, but also the leaf. Now, when I go to the next row, I have a stem, but no leaves. Since I have no leaves, no values are going to be in the 20s. Heading on to the 30s, we have a value of 3 for our stem and a 0 for our 1. So together that makes a perfect 30. Followed by values of 41, 41, and 43. These are all the values represented in our stem and leaf plot. Continuing on. So now that we know how to take values from a stem and leaf plot, we're going to figure out how to make them. So in order to make your own stem and leaf plot, first you must always order your data from least to greatest. Since the data is displayed in your stem and leaf plot from least to greatest, it's helpful to have that in order from the start. Then next, you need to figure out what key best fits your data. So depending on how large your numbers are, whether they incorporate decimals, percentages, make a key that fits your data set. On this stem and leaf plot, this is just the same one from the first page. Again, we have 2 representing our tens place, 3 representing our ones place, forming the number 23. But we have all sorts of different examples over here where we have a stem of 1 and a leaf of 5, and that forms 1.5. So always be certain to look at your key because you never want to make an assumption that's false. Now, step 3, create your stem and leaf plot. Once you've organized your data and you've figured out what your key is going to look like, you have the ability to actually create your stem and leaf plot. So let's do it. Nursery owners, Mr. and Mrs. Smith, recorded the total number of different kinds of flowers, plants, and trees in their neighborhood, and trees their neighbors had in their front yard. The data Mr. and Mrs. Smith collected is shown below. So we have some people with 10 flowers, plants, and trees, 7, 8, 20, 22, 22, 9, 37, 12, 12, 13, and 4. So those are our data points. Now, we're trying to create a stem and leaf. So we're going to follow our 3 steps that I mentioned on the previous page. Step 1, order from least to greatest. So I'm going to take my points and order them from least to greatest. Awesome. So I have ordered my data from least to greatest. And now that I've done this, I get to figure out what key would be best used to represent my data. Looking at my values, they're relatively small. I have numbers ranging from 4 to 37. So I don't need to worry about really creating a complex key. I'm going to use the same key that was used on the previous example. And when you're making your key, you can choose any of your points to create it. So I'm just going to choose the point 12. And for my key, if I have a 1 on my stem and a 2 on my leaf, that means 12. So now that I have that filled in, I can create a stem and leaf plot that fits this data. We always go from least to greatest. So starting with my 4, I have no value in the tens place, but I do have a 4 in the ones place. When I have no value in the tens place, that's like having a 0 in the tens place and a 4 on my leaf. Handled. Now moving on to the 7, that's a 0 in the tens place and a 7 on the leaf, 8 and 9. Those are my 4 numbers that all have a 0 in the tens place, and we're done with that row. So now starting with 10, I was not able to fill that in on my first row because 10 has a 1 in the tens place. So I'm going to start a new stem. I have a 1 in my tens place, and to make 10, I need a 0 on my leaf. Then I'm going to create 2 12s. Although they just look like 2s, each one of those 2s is actually 12 when you factor in the stem. And then 13. 1 on the stem and a 3 on my leaf. Continuing on to my values in my 20s, I'm going to start a new stem with a 2 since each of these have a 2 in the tens place. And I'm going to have a 0 to form 20. 22, it's going to look like this because you have a 2 in the tens place and a 2 in the ones place. Another 22, so I have to factor in a 2 there. And lastly, I have to make 37. 37 has a 3 in the tens place and a 7 in the ones place. This is our stem and leaf plot for the values we were given. Now, continuing on, we're going to be analyzing a stem and leaf plot. Stem and leaf plots, when they're given to us here, can be clear, but sometimes it's overwhelming to some people. So what I would recommend doing is anytime you're given a stem and leaf plot, don't hesitate to copy down the values that are present in there so you don't get confused when you're asked to find measures of center and asked to analyze the plot further. So I'm going to take my stem and leaf plot and figure out what numbers are on there. Starting here at the top, I have a stem of 0 and a leaf of 1, so that's really just 1. Then 3, 5, and 7. Those are always nice and easy when you have a stem of 0. Now moving on to here, might look like I have a 0, but this is actually the number 10 because we have a 1 in the tens place and a 0 in the ones place. This is confirmed from my key down below. Then I have 2 12s. And then my last number is 22. A lot of people want to put down 30, but we can't mark this as 30 because there's a stem but no leaf. If 30 was present, we would have a 0 on the leaf, but we don't here. So we're going to continue on with this list. Okay. Now, in order to answer these questions, we have to remember our measures of center lesson from last week. So mode is our number that occurs most often. Looking at this data set, I would see that 12 was repeated more times than any of the others. So 12 is going to be my mode. You can also figure this out by looking at each of the individual rows on your stem and leaf plot. I see that 2 repeats twice in this row, which means that it counts for the same number, and that number really is 12. Do not tell me the mode is 2 because these are not just plain 2s. These are 12s because they're on the row with a stem of 1. Range. Range is always your biggest number minus your smallest number. So what I need to do is identify my largest and smallest numbers. 22 is my biggest number, and my smallest number is 1. So I'm going to subtract those two values. 22 minus 1 is 21. And 21 is my correct answer. Heading down to median. Median requires us to find our middle number. So we always order from least to greatest, but how nice that the stem and leaf did that for us. And we already took our values out, so I'm just going to copy them down here. So I have them handy underneath median. You can always cross off from the ones above, but I just like to have it written down separately. So median, we have to cross off and find out what's in the middle. Can get rid of 2 over here, then I have to go back and do 2 over here. Then 1, 1, and I'm left with 7 and 10. So whenever you're left with 2 numbers, you need to find out what's in the middle of both of them. And to find out what's in the middle, you have to add them together and then divide by how many you added. So 7 plus 10, and then I'm going to have to divide that by 2 because I'm averaging 2 numbers. 7 plus 10 is 17. And then I'm going to have to divide that by 2. 17 divided by 2 takes me to 8.5 or 8.5. 8.5 is going to be my median. Lastly, mean, the meanest one. So what we're going to have to do here is add every single one of our values together. So you can do this in a variety of different ways. I like to kind of group them together and add them from there. But 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 6 is 16. Or sorry, 9 plus 7 is 16. 16 plus 10 is 26. So I'm just going to stop there, put a little tick mark. And I have 26 factored into there. I know 12 and 12 are fairly easy to add together. That just gives me 24. And then my last number is 22. So now I just have to add all these 3 numbers together and I get 72. Now, if mean was just adding everything together, that wouldn't really be that mean. So we have to go one extra step. We add everything together and then we divide by how many numbers we added, which were 1, 2, 3, 4, 5, 6, 7, 8 values. And 72 divided by 8 takes us to 9. 9 is going to be our mean. So we used a stem and leaf plot to find mode, range, median, and mean. And now we're going to use a stem and leaf plot to analyze this one step further, okay? So this question asks us, what percent of the homerooms had more than 10 students receive Candygrams? So we need to find the percent of the homerooms that had more than 10 students receive these Candygrams. So what I'm going to do here is fill out a proportion. You guys remember from our percent unit, I always encourage you to fill out proportions. It's a great way to anchor your thinking and really make sure you look for scale factors if they're present and not make careless errors along the way. So the second I see this word percent, I know that percents are always out of 100. So I'm going to fill that in first. Your percent is your part out of your whole. Now, we're looking for the percent that represents the number of homerooms that had more than 10 students receive Candygrams. So my percent is on my top row. So that needs to account for the number that had more than 10 receive Candygrams, okay? And we always have our part out of our whole, so I'm gonna put total on bottom, okay? So now we have to go into our data that we have here. This is why it's helpful to have it written out and figure out how many had more than 10 students receive Candygrams. So we want more than 10, so this 10 doesn't count. 12, 12, and 22 are the 3 homeroom classes that received more than 10. So 3 out of 8 received more than 10, okay? So that's 3 out of our total 8, because we had 8 different answers. So now that we have our proportion set up, we need to solve it. There are so many different ways you can solve proportions, and I encourage you to use the method that you think is most friendly to you or that you're most comfortable with. There's a variety of different ways. I'm going to show you 2 different ways that you can use. The first way is by finding a scale factor. So if you guys remember from our benchmarks that we memorized, to get from 8 to 100, you can multiply by 12.5, okay? 8 times 12.5 takes you to 100 exactly. Now, if you guys remember from before, I encouraged you that whatever you did to the bottom, you do to the top, because you need to make sure that your proportion stays balanced. So we would multiply that times 12.52, okay? So when I multiply 12.5 times 3, I wind up with an answer of 37.5, okay? And when my percent logo is there, that means my answer should be in percent form, which is 37.5%, okay? That would be my final answer there, that 37.5% of the homerooms had more than 10 students receive Candygrams. Now, if you can't remember that there's a nice scale factor of 12.5, that is perfectly fine. Sometimes we don't have numbers like this that go into 100 evenly, and we need to figure out how to cope with that. And another way we can deal with that is by cross-multiplying and dividing. So I'm going to eliminate this so we have a little bit more room to see what I mean. So 3/8 is equal to some percent out of 100, and I encourage you guys to cross-multiply and divide to solve sometimes. So 3 times 100 is 300, and then you divide by the value that's left, which is 8. Can 8 go into 3? No. Can 8 go into 30? Yes. 8 can go into 30 3 times, and we land at 24. When I subtract 30 and 24, I get 6. Can 8 go into 6? No. So I'm going to drag that 0 down. Can 8 go into 60? Yes, 7 times. I end up getting 56, and I'm left with 4. Can 8 go into 4? No. Now I no longer have any values to bring down, so I'm going to add a decimal point, which affords me the opportunity to put in a 0. Can 8 go into 40? Yes, 5 times. So I cross multiplied and divided, and I got my same exact answer of 37.5%. Please make sure you set up proportions on those percent problems because it will be incredibly helpful as far as getting accurate answers. If you have any questions about anything that I went over in this video, please feel free to reach out to me via It's Learning Messenger, email, also by showing up at any of our 3 office hours. Thank you so much for paying attention and following along. I greatly appreciate you. Good luck on your exit ticket and classwork. Thank you.